Alright, you guys, we've got more uniform motion problems. So, uniform motion, unequal distances. So we've done equal distances and we've got done when two people go a total distance and you get a sum of that. So some of our pictures look like this, where we have equal distances, and some of them have looked like this, where we're adding two distances together. And now we have unequal distances. So at 8 p.m., Achilles left camp and headed south at 20 kilometers per hour. At 10 p.m., Patroclus headed south from the same camp. If Patroclus was 50 kilometers ahead by 3 a.m., what was his speed? So let's draw a picture. So Achilles left at 8 p.m., so I have distance Achilles. And then we've got the Pat guy, his distance, and then by the end of it, he was 50 kilometers ahead. So distance P, he's got to be 50 ahead. So whoever went less time, you guys, is who we have to actually add a distance to. So the distance of Pat was 50 kilometers more than the distance of Achilles. So let's write our first equation. So we have the distance of Achilles plus 50 equals distance Pat. And we're going to replace it with rate times time, like we always do. That's a P right there. Okay. So let's see. Achilles left camp and headed south at 20 kilometers per hour. So 20 kilometers per hour is Achilles' rate. And we want to actually find Pat's speed, so we're going to look for that. But we've got 8 p.m. is when Achilles left camp, and then at 10 p.m. Pat left camp, and we're ending at 3 a.m. So how much time is it from 8 p.m. to 3 a.m.? That would be 7 hours. And then from 10 p.m. to 3 a.m., how much time would that be? That would be 5 hours. That's going to get plugged in for time Pat. And now we can solve for our rate. So 20 times 7 is 140. And let's put the 5 in front here. So add 140 and 50, that's going to be 190 equals 5 RP. And we're going to divide both sides by 5, and we get 38 for RP. Don't forget your units. So we're solving for rate, and this one's in kilometers per hour. And that's all the problem was asking for. So let's try another one before you guys try it. So Harry and Jeanette jog around a circular track that is 210 meters long. Jeanette's rate is 230 meters per minute, while Harry's rate is only 200 meters per minute. In how many minutes will Jeanette be a full lap ahead? So if we draw a picture, we've got the distance of Harry, and we've got the distance of Jeanette. So Jeanette went a full lap ahead of Harry. So whoever went less is who we have to add the distance to. And the track is 210 meters, so that's how much we're going to have to add if she's one track lap ahead. So our equation is going to be distance Harry plus 210 equals distance Jeanette. And then we're going to replace, of course, our distances with rate times time. And see what we can plug in. So Jeanette's rate is 230 meters per minute. So for RJ, we're going to plug in 230. And Harry's rate is only 200 per minute, so we'll plug 200 in for Harry's rate. In how many minutes will Jeanette be a full lap ahead? So for this one, they didn't give us any times. We actually started at the same time, but Jeanette just went a lot faster. So for this problem, our times are actually equal to each other. And so I'm just going to use TH. and I'm going to replace TJ with TH since they're the same. All right, so I have 200 TH. I'm going to subtract this one so I have like terms. Let's subtract 200 TH from both sides. So I have 210 equals 30 TH. And let's divide both sides by 30. And we get 7 for our time. So let's see what the question actually asked. In how many minutes will Jeanette be a full lap ahead? So the time for both, they're equal times, so is 7 minutes. All right, now you guys can try one on the whiteboards, and you can just pause it so that this stays up, and you guys can try it out yourself.